Hello and welcome everyone to roll call number 4. That's issue 1013 in the Ethereum PM's repo. I'll drop a link in the chat. Yeah, let's get started. So, as I'm sure you know, we skipped the last call that was scheduled for just after the go live of EIP 4844. It seems like that went very successfully, both from an L1 perspective and then from many of you here deploying blobs on the L2 side of things. I was going through the base fee recently. It's also the blob base fee that has been interesting to see. It seems like we're still just hanging under the threshold or the target of 3. So blob base fee is nice and low, particularly now that the descriptions have died down, which is really cool to see. And excited that this seems to be bringing down the costs for many people. Yeah. The other exciting thing that's sort of happened since our last roll call is we've seen RIP 7212 R1 precompile go live on several chains. Congrats to everyone who's deployed that. This is really awesome. And yeah, I'm excited to see the direction this goes. But I think it's a big unlock from a UX perspective, as you're all aware. So
I think
yeah,
EIP's, well, RIP 7212 is also scheduled for Pectra.
yeah. Wait, is it?
I've seen it in the mega thread.
Okay, I didn't realize it was scheduled. I mean,
It's
that's
not
also
scheduled yet.
Yeah.
It's just being considered.
I mean, would be cool, and it's definitely something we can push on the L1 side and see if there's interest to have it deployed on the L1 side as well.
So I guess from a Rollup perspective, everyone that wants to add SGX, and I think there are several, at least Tycho does. I've seen Scroll mention it as well. This would help on gas costs, like reducing just the SGX verification from 1 million to 100,000 or something.
Okay, that'd be pretty cool. Yeah, that definitely goes from the realm of barely feasible to definitely doable within a block. Okay. Any other things people want to mention on 7212? Great. Moving on, the next topic is the BLS precompile on layer 1 that I'm sure you guys, everyone here, has seen lots of discussion on in our chats. Alex was going to pitch it, but I believe he's unable to make it. The idea here, and the reason this is important to discuss in this forum, is for the chains that are targeting EVM equivalents, particularly on the ZK side, it could be quite complicated to have the support the BLS precompile, the EIP 2537. And so this is something that will happen on L1 mainnet. So the question is just like, is this something that the ZK-L2s feel like they can implement, or would it is it something that we need to figure out a standard for having to work around not supporting on the L2 side of things? Is this just something we can solve with gas being different on L2? Does anyone have any thoughts on this?
Well, Taiko is not live, so we have less constraint, but we are adding support to the BLS 12 381 precompile. I mean, once you support BN254, modifying to support BLS 12 381 is not that hard, at least for addition and scalar multiplication. Hashing to curve is a bit different.
And the reason hashing to curve is less fun. What's
So there are two reasons. One is that there is no hashing to curve for BN254, so we need to
Yep.
write the code from scratch. And the other one was even if it uses BLS 12381 uses SWU algorithm, while BN254 uses SVDW.
Okay. All right. And then the other thing that I think many people have seen discussed and what was being discussed um, in the chats was in relation to whether we should do the subgroup checks and which function should have subgroup checks. I mean, that's a larger discussion and I think will be solved largely at the L1 side of things, but is there anything that's like, does this have any effect on those trying to implement it in ZK crypto?
So the way subgroup checks are done is through a scalar multiplication, but a very short one. So once you support scalar multiplication in ZK, subgroup checks are kind of free.
Okay, so you're not worried. There are no concerns about the additional costs of it's less about whether it's feasible. It's more about just the marginal cost of how frequently it gets done,
Yeah.
and that's
So and
not too bad then.
on the gas cost, I guess there is a tension between like if we want people to verify ZK on chain for cheap, we need the gas cost to be very low. But at the same time, for layer 2, if people want to use ZK bridges, maybe layer 3s and everything, we need to be able to do those. Like it should be able to reflect proof of cost on layer 2. But this is only an issue for type 1 rollups. And the only one that's type 1 at the moment, like there is none. Tyco will launch at type 1. We'll add some precompiles to, well, syscalls, accelerators, coprocessors, whatever people name it, to make sure it works. But yeah, it's there's a tension there for sure, and this is also why I raised EIP 7667 from Vitalik, which was about raising the gas cost of hash functions by 10x to reflect a bit the cost in ZK EVM, in Type 1 ZK EVM of proving hash functions. But the difference for elliptic curves operations is that if you use like Aztec, Goblin, Plonk, or CycleFold, you can actually reduce the cost of elliptic curve operation proving. While you cannot do this with hash functions, there is a lot of research with lookup singularity, BNews, and things like this, but nothing in production yet.
Okay. I think that's helpful. Anyone have any other things they'd like to raise on to be a less precompile, particularly with relevance to L2. Nope. Okay, great. Moving on. So the next one is EIP 7623, which is aiming at increasing call data costs. And I believe Tony wants to speak about that. Over to you, Tony.
Yes, thanks a lot, Carl. Hi, everyone. Let me quickly drop some links here in the chat. Yes. So in the chat, you can see the link to the EAP itself, then the latest analysis, and also you find this GitHub pages page where you can look for functions that some stats on different functions and check which functions are essentially affected by the EIP. But to give you some background, so EIP 7623 is basically proposing to raise the costs for call data. So basically increasing it from 4 gas per 0 byte and 16 gas per non-zero byte to 48 for non-zero bytes and 16, I think now, or 12. I would have to check it again, but definitely increasing it for both. And the rationale behind this change would be to just lower the maximum possible block size. And I thought it might be important to also introduce this EAP specifically here in the rollup call, because in the end, it's the rollups that are currently the biggest call data consumers. And although most rollups have already switched towards using blobs, there are still some rollups that are dependent on cheap call data. I guess until Pectra, most of the rollups might have moved to using blobs anyway. But yeah, there are still some edge cases where certain rollups might still need to use call data, especially if you need that call data inside the EVM, if you want to do something with it, then those rollups might be affected. And although the EIP is currently not considered for Pectra, I think there's still a way for the EIP to make it into the update. So I'm super curious about opinions on it. Basically, what the EIP does is it introduces a floor price. When you use a certain amount of gas on EVM computation, you don't hit that floor price, which means you get the call data at the same price as of now, which is 4 and 16 gas per byte. But if you're a pure data availability consumer on layer one, then you might have to pay more for that. And this allows us to reduce the block size from currently 3.5 megabyte, including blobs now, to around 1.9 megabyte. So it's almost halving the block size here. And why do we want to reduce the maximum possible block size? That's one question you might ask. And the reason is because the current block size is quite large. So 3.5 megabyte is arguably quite large. And while the current block size is around, the average block size is around 100 to 200 kilobytes. So there is a big room between, let's say, 200 kilobytes and 3.5 megabytes. And in order to get to such a 3.5 megabyte block, you would basically create one single transaction with a lot of call data and get it into a block. So there's no real use case except for creating these very, very big transactions that, I'm not aware of any use case, and there weren't such big transactions that really consumed the whole gas that is available in the block within one transaction. So in my opinion, it makes sense to make sure that the block size is reduced a bit and paving the way for further scaling, because there, as you might have seen, there's a draft EIP, I think, for increasing the blob count. And there is also pumpthegas.org, which is kind of a community effort to increase the gas limit. And I think this should be taken very seriously, because I think the community has voiced a demand to increase the gas limit. And yeah, we can discuss if there is room. So probably the Cordafs can tell us if there is room to increase the gas limit without changing anything in the call data. Because of course, the bigger the gas limit, the more call data you can get into one block, and the bigger the blocks are. So yeah, curious what people think about that. I think there were already some core devs saying, okay, we shouldn't naively increase the block gas limit because we already have very large blocks. And then, of course, the question is, how do we best deal with the block size? EAP 7623 is one attempt. I've not heard about other attempts to achieve the same goal, but of course, there might be different ways towards that goal. And yeah, super curious what people think, especially if you're representing a rollup, if you're working for a rollup. I'm super curious if this would even affect you, if this would affect you as a rollup, because most rollups, I guess, would be unaffected entirely. Yeah, so curious what people think. Even if you're for it, against it, I'm curious to hear about different opinions.
So assuming you've
Fine.
switched over to,
Fine.
oh, yeah.
Yeah, no, I
Go
mean, the very end rollup will choose between which is most cheaper, either call data or either blob. So if you increase the call data cost, at the very end, more rollups will move in order to put the data availability to the blobs, I guess.
Which is good, right? Because the rollup data has kind of the better place for rollup data are the blobs, right? So this might be a positive aspect to kind of strengthen.
I mean,
the
kind of
switch.
it's kind of forcing to switch, which is, I mean, it's not good, no, because at the very end, no, not good, because you're forcing rollups to move to blobs. But I mean, if it's not forcing in the short time, I think it's better. Maybe in the midterm, it would be better for rollups in order to adapt perfectly to the blobs.
So this the threshold at which you do sufficient compute such that the call data cost isn't at this higher level, would we be reaching that threshold with, for example, a Ford proof, or does this mean that Ford proofs would become more expensive? Do you have any insight into that?
Actually, you would have to tell me how much call data such fraud proofs need, because I can tell you that it's around 97% of the transactions would be unaffected. So this means there are not many transactions currently that would be affected. I know that there are some very big Merkle proofs that might be affected by that, because certain Merkle proofs, they don't use a lot of EVM operations, EVM computation, but they require very big call data inputs that are then, of course, used inside the EVM. Yeah, I'm not sure about fraud proofs. I guess as soon as you use the EVM, as soon as your transaction involves the EVM to a certain extent, so I think it's 2x, so you have to spend 2x the amount on EVM gas, 2x the amount of gas on EVM computation compared to call data, then you're already in that range where you don't hit the floor. And currently it's as said, 97% of the transactions of last week would be unaffected. And those 3% of the transactions that would be affected were executed by 1% of the users. So the number of users that are affected is very small. Currently, I think Scroll hasn't switched to using blobs, what I saw. So they would still be they would, if we would ship that today, they would be affected. And also Starknet. So I'm not sure if someone from Starknet is here, but I think also the Stark proofs, they are very big, and they also need those need that data, the call data, inside the EVM. So I'm not sure if there is something to optimize or if there is another way for them. But as soon as you require a lot of call data, but you only touch the EVM a little bit, then you are affected. And also, maybe to add that most of the affected users today would be those that add messages to their transactions. So if you withdraw from some exchange and the exchange lets you put in a message in your call data, you might have seen that, then you're affected, but only very negligible because the messages are usually very small. So this is not a big concern. It's more those that have very big call data and still need it inside the EVM.
So what about future use cases where you're using a lot of ZK proofs that you need to include in the call data? Like not, you know, that they're different, that, you know, sufficiently different that it's not good for aggregation and recursive proving. So what do you do then?
Are you thinking of ZK coprocessors like Axiom, Herodotus, or Lagrange?
No, just in a regular, let's say like a DeFi use case where you want to do trades, right? Or more, you know, more complex trades, and you want to make sure that your that the trades are compliant, and you're using zero knowledge proofs as assertions that you know, sender, recipients, etc. are proper, properly KYC'd, that the assets that are being traded are not hitting any asset policies, you know, maximum volume of trading per day, suitability, for example, is the account purchasing that suitable for that type of asset. That's a compliance thing, right? It's like if that account belongs, you know, if it's a highly speculative asset and the account belongs to a 95-year-old, that's not suitable, right? So you have to have these ways to prove that, and the easiest way to do that without revealing information, if you want to do it on chain, whether that's L1 or L2, doesn't matter, is using ZKs. So there are use cases where you could have, you know, 8, 10 different ZKs in a for a single DeFi trade.
Okay, yeah, I see. Yeah, usually if you use snarks, for example, then in all the cases I saw so far, you're not affected because it's just so much EVM computation that you need to verify a snark. That there's a difference for Starks. So I think when it comes to CK,
but the inputs, it depends on the inputs, right? I mean,
right.
Inputs could be they can, depending on what the inputs are, how many there are, that will drive call data size, things like that.
Right. But yeah, as you say, it's dependent on the input, how much input such use cases would eventually need. I don't know, if you look at Tornado Cash, for example, today, the inputs are small enough to not hit the floor because it's, I think Tornado Cash has 500K gas, the one transaction, so deposit or withdrawal is 500 gas, while the inputs, I think you have, I don't know, 5, 6 parameters that you need in your call data. So this is still not enough to causing hitting the floor. So
Yeah, I'm looking at use cases where they're you know, unless you're going to like a semi-private approach, where where the input is just the root hash, you have you could easily have 40, 50, 60 input parameters.
right, and that's also
Right,
where
because you have different keys, and you know when you decompose. So it's like it's that there are use cases where you can have large number of public inputs.
Mhm. Yeah, I see that point. It's very similar to the big Merkle proof point where you also need to
Yeah.
provide the whole path. Yeah, I think it's a very individual thing. So one would have to look into the individual transaction to check if they would be affected or not. Maybe to highlight, those use cases would not become impossible, right? They would just become more expensive.
More expensive, yeah.
Yeah, and for example, with Starks, I think it was around 30% more gas. So a Stark proof would be 30% more gas, for example. And of course, this could be compensated by increasing the blob count, by increasing the gas limit, by just making the whole thing cheaper. But this is, of course, a little, yeah, this is an unknown. So we cannot really tell. But that's a good
No, I
point.
just wanted to bring that up as another use case, which is kind of general. What if you're dealing with a lot of snarks, which I think we're going to see more and more of.
Yes, I agree to that. Yeah, I to highlight that again. There's this. I think the third link I posted shows you all the functions, and there you can see which functions are currently affected, and you can see it's functions like commit batch, which is a function used by scroll, which is currently affected and would be increased by 100%. And others are like there are mint functions, but they are rarely used. For example, there are other functions like verify Merkle, which takes two lists of uint 265, which might be affected. And of course, the verify FRE, which is the function that Starkware uses. So on that link, if you're a rollup operator, you can check if functions that you call, if they would be affected. But so far, what I have seen, it's only Starkware that will still be affected, because all the other rollups can kind of flee towards using blobs. I see Ansgar wrote something. Let me check. Yeah, Ansgar wrote, now that we have blobs, the call data increase seems inevitable. Expensive call applies to call. Right. Yeah, I agree, Ansgar. CK proofs in general, snarks are usually very small, like Tornado Cache, and they come with the verification takes a lot of AVM resources. So snarks that we know them today, like Tornado Cache, for example, they wouldn't be affected at all. So they are way above this threshold using enough EVM operations to do that.
Regarding your option for full 2D pricing for call data with a market similar to EIP 1559, I assume this one is not scheduled because this is too complex to implement for Pectra, which is less than 6 months from now, I assume.
Yeah, so this was also the main feedback I got so far regarding that point, that kind of having a separate fee market for call data might be just an overkill for the thing we want to achieve, which is basically just lowering the maximum possible block size to prevent DOS attacks. And yeah, so of course, having a separate fee market would be also a very clean solution but maybe just over engineering the whole thing or too complex. I think Ansgar once had this comment like, why don't we just have a separate fee market for every upcode then, which might be the next step in
So
this discussion then.
I think
But yeah.
when Rollup like 2 years or 3 years ago, all Rollups were discussing 2D fee market. If you search on ETH research, there might be several instances, so there might be for it, but the burden of implementation is on the execution layer, and we need buy-in from them for this. And then you need also wallets to implement this. So I think 6 months is way too low. And if there are like, it would be very interesting, but if we want something for Pectra, we need a smaller solution. And then the question is it good enough, or will we need yet another art fork to fix this again?
Right, yeah. I agree. Yeah, I fully agree. And it would also be the question would then be, do we then achieve the goal of reducing the block size, right? Because imagine all rollups switch towards blobs, then call data becomes cheaper again, and suddenly with cheap call data, one could again create those very big blocks that might cause some troubles, especially thinking of smaller stakers that cannot that don't have the bandwidth to keep up. But this is super interesting. Would be cool if you could send me a link or something. I would love to see that discussion. I haven't seen that so far.
Ansgar?
Yeah, on this topic, I just wanted to briefly mention there's nothing actionable right now, but I was also working on like multi-dimensional fee markets like a year and a half ago or something for a while, and in general kind of more repricing flexibility. I think there's a lot of pent-up demand around doing this, especially as layer 2s structurally become less and less similar to L1, especially say in just throughput numbers. You might have seen the kind of, for example, Base has been very active on like memeing about wanting to like 400x the throughput. But I know that a lot of layer 2s are working on similar plans in the background. Once you do that, you basically just hit very different constraints than L1. And so basically having the exact same pricing schedule, even if you stay on a one-dimensional pricing scheme, just doesn't make sense. So basically the question around how can we have more flexibility in like having different pricing schedules for different VMs without breaking interoperability of apps. How can we maybe introduce multi-dimensional pricing? There's a lot of kind of just pent up ideas and research and everything. I would expect that over the next 1 to 2 to 3 years, this will somehow lead to some more fundamental revamp of the fee market and some actionable things for maybe just for layer 2s, maybe also for layer 1. So for me, in my mind, basically, we are in this phase where right now we are just trying to have like small, minimum intrusive adjustments that basically get us to this more fundamental rework. And I think basically Tony's CIP is perfect for that.
Great. Anyone else want to mention anything on this EIP before we move forward?
Maybe if someone is very strongly against it, especially including it into Pectra, I will also present the EIP and propose it to include it into Pectra tomorrow in the RollCall devs call. So yeah, just feel free to join and raise your voice there if you don't want to see it into Pectra, or contact me. I'm happy to discuss it.
Great. Thanks, Tony.
Maybe ping people from ZK coprocessors. I'm not sure how they use cold data, but they might need a lot of data as well.
Okay, yeah, thanks. Thanks for that input.
Great, and then I believe Mami also wanted to talk about EIP 7667, which is an EIP to increase the gas cost of hashing precompiles. Mami?
Yeah. So Vitalik proposed 2 weeks ago to increase gas costs of hash functions. Obviously, for type 1 rollups, that's great because hash functions have a disproportionate proving cost. But I'm wondering, like, should we just say, yeah, all rollups agree with this? That's basically the kind of consensus I'm looking into, because I assume other dApps developer, for example, the one that use Merkle trees on chain, will say, oh no, this becomes too expensive for us, and there will need to be a discussion and arbitrage in terms of do we increase 2x, 3x, 5x, or do nothing, for example.
I think the thing I'm a little unclear on is why, like from an L1 perspective, more than obviously is there's benefit for type 1 L2s, but from an L1 perspective, why is it something that needs to be done now as opposed to in the future?
So that was asked by WGM Elements. And what did Vitalik reply? Yeah, making things unviable, and so that they come to other solutions before, instead of them building something and then 1 year later it cannot be, it's dead in the water. So I guess it's managing expectations. Personally,
okay.
I have no opinion on when to do this.
Yeah, I mean, I can definitely see the argument for wanting to do it sooner from the perspective of setting expectations that would prevent, yeah, issues where people are unduly impacted, such as Tony was mentioning earlier with his EIP, where certain use cases suddenly become radically less possible or more possible. Anyone else want to raise any additional points on this EIP?
No, that's all. Just raising awareness and seeing if there is some kind of consensus on rollups, or if people maybe don't care, neutral.
Would it not make sense to offer the option? I mean, increase the cost on the L2 rather than the L1, right? And for fact check, and offer an alternative on the L2 like Poseidon 2. right? Because from a smart contract point of view, if you're using hashing is hashing, right? As far as the logic goes, right? Obviously, from a proving point of view, there's a huge difference. So if you just introduce different pricing for, hey, if you use CAC-JACK, well, that's going to cost you like 10x more or 20x more than if you're using like Poseidon 2. We also have a precompile for that. Thoughts about that?
I think that's a very interesting point. I think you should add it. Maybe it should come with a Poseidon hash function for based on both BN254 and maybe one for BLS 12381.
Yeah. Doesn't Poseidon 2 work like very effectively for both?
Yeah, but maybe we should have an EIP that implements both, so that people are not again, or there is only Poseidon on BN, so I'll build only BN.
Oh, yeah. Of course, yeah.
Is the idea to have this then as a precompile?
Yeah. So
Okay.
you give options, right? You give options for the smart contract devs. It's like, look, if you do this, costs you more money. It's more like what you're used to. But if you're writing code for an L2, and by the way, it would not hurt if you had precompiles for like Poseidon 2 on BN and BLS on the L1 too, because that would make life easier for for ZK type applications, right? Because then you can compute Poseidon hashes on L1 that you might need for public inputs, etc. So that there's also a general upside if you want to make the L1 more ZK friendly, to support something like Poseidon on VN and BLS.
I imagine the issue of getting this kind of thing on L1 will be the relative novelty of Poseidon.
I just picked Poseidon out of the hat,
Sure. But
it's like you would have to discuss which would be the type of hash function that would be supported, because that basically would become a forcing function, right?
Sure, but I mean it's a more general issue of arithmetic hash functions.
Yes,
like their relative novelty, and they're like these are things we have to maintain in perpetuity on the L1 side.
It's doubtful that's going to go away, but point, right? Yeah, sure. If you want to and I said you can do two. They are not coupled, right? You can do just the stuff on the L2 and not do it on the L1 and do the L1 later. But for offering something like that on the L2 would definitely lessen the pressure on the L2s. If you gave the developers the options.
Yep. No, agreed. All those things are relevant, and that's largely why we set up this call, is to be able to ship these kinds of things on L2s that might be necessary. But L1s aren't necessarily, the L1 isn't necessarily ready or willing to ship. Great. I think that brings us into general discussion. Does anyone have any other points that they wish to raise?
Yeah, so I would just wanted to bring up a point, since we had discussed like L2 transaction fees. So the L2 standards working group over at Oasis has come up with a proposal for an API spec, and I thought it might be a good time to have a breakout session on that with like the different client teams to take a look at it and see what they think. Because it aligns with like, you know, separating out the fees in the different components, etc. Execution fee, data fee, priority fee, what already has been discussed. So I just want to propose that and see if people would be interested.
Yeah, I mean, naturally, I imagine that's the kind of thing that there's demand for. And you're always welcome to host your own breakout on this. Any other topics?
Maybe just to briefly mention to what Andreas just said, I think basically that just to add, I think basically the two separate aspects of the actual protocol changes, like having some sort of consistent transaction type for this, and then the API changes around this. And I think ideally an ideal kind of approach would combine the two. But of course, any protocol changes would require much more buy-in from the different teams to move to a new kind of transaction type system. So I think on the RollCall side, a breakout would probably be good once we can kind of have some sort of feeling for how to best tackle the actual kind of in protocol changes as well. But I'm definitely open to also having at some point having some sort of breakout session on more the API changes standalone otherwise. Because otherwise, maybe it's not a good idea to have them blocked by a need for in protocol changes.
Yeah, I think I mean, the APIs are simple enough that they should, you know, all that information should be available. So I don't think that there would be like, I mean, it might be different for each client, but I wouldn't perceive that there should be like any protocol changes on the client side, right? The data is being computed today, so it's just a question of exposing that.
Right. Yeah, I'll have a look and see whether that makes sense to have like some sort of roll call kind of organized breakout. I can chat with you about that, but then we can maybe have something announced next roll call and have it then kind of in the cycle after. Or otherwise, alternatively, maybe have something more on the Oasis side, and then we just highlight it on roll call or something. Either way, basically, but have a follow up next roll call.
Yeah, so we have. I mean, we're basically ready to say, hey, this is a proposal. It's like, what do you guys think? We're at that point. So it's like with like, you know, Meta Labs and Off-Chain and Optimism and so forth.
Sounds good. Sounds good.
Okay, cool.
And then, Carl, because you was asking about other topics, so there was just one topic I briefly wanted to mention, and that's more like on a meta level, just for people to kind of maybe think a little bit about kind of the general kind of future role of RollCall. So Carl and I and Yoav, we've been kind of talking about this as well over the past few months. And maybe so just for context for other people. So the way I see it is that RollCall kind of course started as a bit of an experimental project, and I think by now I see three separate distinct kind of categories of uses for this process shaping out. And so the first one would be just a general connective tissue between layer 1 and layer 2. So that's like a little bit like what we saw today, the conversation around the call data EIP, BLS EIPs, that kind of thing. So basically both representing layer 1 towards layer 2s and the other way around, representing layer 2s towards layer 1, making sure that everyone is kind of tied into the respective kind of governance processes, and we have less friction there. So that's kind of number one. And I feel like we are already kind of on a good path there in terms of filling that kind of gap a little bit. Then the second one is what I would say is more general kind of, well, I would say research. That's things like fee markets, everything. I feel like we had the breakout calls, which were a little bit more experiments. Of course, we haven't really followed up on those yet because general feedback was that weekly calls was a bit much. So the question is, do we keep that up in the future? Basically, where is there a need for, say, kind of cross layer 2 research collaboration? So that's a little bit something where we are still kind of evaluating. And so if people have feedback, like where these initial breakout calls we had a few months ago, were they useful? Would people want to basically start that back up? And that's definitely something that we'd be interested in hearing about. And then the third one, that's I think the most ambitious side of the future for RollCall would be what I would say is, well, on the one hand, like say just like layer 2 ERCs or something. That's of course something we can do at any time. That's something like this fee market API change or something. But I think even more interesting, of course, would be the RIPs. So potential future extensions of the EVM on layer 2. I think there the situation we are in right now is that so far it is shown to be, and that was of course predictable, it's shown to be relatively hard to ship any kind of changes that meaningfully deviate from layer 1, just because for now there is no good process of having support for these kind of changes in clients for layer 2s. So for now we are really limited to these IPs like the R1 precompile, which happen to be so tiny implementation wise that Geth in this case just opted to support this, even while it's not actively targeting layer 1 yet, or at least not accepted for layer 1. But of course, that's an anomaly. Most interesting layer 2 IPs would require deeper changes, and it's not clear yet in what form these could be shipped. So I think for now, basically, the RollCall is a little bit, and I don't want to say blocked, but basically, we're in a position where we yet have to figure out a good path. We have some ideas there. It's maybe too early to really discuss those, but that's definitely topics for future breakout calls. So far, we have talked to individual client teams about how kind of a path forward to giving more options, more possibilities of these kind of more ambitious IPs in the future. And we're also over the next few weeks going to start talking more to some of you all on the layer 2 team side. And so I just wanted to bring it up already, because I think these calls for now, it's also like, if you look, there's been attendance is relatively low and everything, because right now it's a little bit still in this experimental stage. And so we're kind of actively working on charting like a path forward to figuring out exactly kind of the shape of RollCall. I just wanted to mention it, of course, if someone has feedback right now, but also more just to think about it. And we'll basically kind of reach out, talk to teams, and yeah, I think the ambition is basically to figure out how this process can be the most useful for you all. So just wanted to give that as like some context.
Sounds good. You want to have anything else they want to add to that, or raise more generally as discussion before we wrap up? Okay, great. Thank you everyone for attending. I will see y'all in the chats.
Thank you. Cheers.
Thank you. Bye bye.
Thank you. Bye bye.